So here in this question we're told that a sample of argon gas occupies 112 millilitres at 25 degrees Celsius and 118 kilopascals pressure. We're asked to what volume will it occupy at 65 degrees Celsius and 78 kilopascals pressure. So to start off with then, I'm going to write down the values that we have. I'm going to say that we have a volume initial equaling to 112 millilitres, that we have a temperature initial equaling to 25 degrees Celsius. We need to convert this into an absolute temperature as we're dealing with ideal gases here. So we have an equation that says the temperature in kelvins, T sub K, is equal to 273 plus the temperature in degrees, often denoted by theta. So simply this in Kelvin would be 25 plus 273, or 298 then, Kelvin. We're also told that we have a pressure initial, little p sub I, is equal to 118 kilopascals. We're given a final temperature, T, let's say sub F, equaling to 65 degrees Celsius. In Kelvin then we'd have 273 plus 65, or quite simply 338 Kelvin. And we're also told a final pressure equaling to 78 kilopascals. So, to start off then, what I usually like to do is just write down the ideal gas equation. Pressure times volume equals number of moles times universal gas constant times temperature. In this case, I would rearrange to make our non-constants, our variables, appear on the left. So, therefore, PV over T is equal to NR. But because the mass of the gas doesn't change, we're not adding any gas, we're not removing any gas, then the number of moles is constant. And what's R? The universal gas constant. That's a constant. And so we can say that that equals a constant. What does this mean? Well, it means that any pressure times volume over temperature, let's say our initial values, that's going to equal the pressure final times volume final over the temperature final. And all we need to do here is rearrange to make the volume final the subject. So therefore, volume final. The way I like to do this is just write down our final term and then think about it as we're going through. So we still have these terms on the left. Pressure initial, volume initial over temperature initial. But then we'll be timesing by temperature final. And then dividing by pressure final. I'm running out of space, so let's bring this up here, and then all we need to do now is plug in our values. So the volume final is equal to pressure initial, which is 118, times volume initial, 112, times the temperature final, 338, divided by the temperature initial, 298, times by the pressure final, 78. And if you were to do that on a calculator, you'd get an answer of 192. What would be the units? Well, the units would be millilitres, as we've kept this as millilitres up here. And that has indeed been quoted to 3 significant figures of accuracy.